Today, we are going to be looking at graphing linear inequalities. So, an inequality are these four symbols here. This first symbol, we say that is less than. The next one is greater than. Now, if we add a line underneath, they become an equal to. So we have a less than or equal to, and a greater than and equal to. So we are graphing lines that instead of an equal sign, we're going to have one of these four inequalities. So let's look at the steps for graphing linear inequalities. First, you are going to plot the y-intercept. Then create another point by using your slope. Then you're going to draw the boundary line. So your boundary line is either going to be a dashed line or a solid line. It's a dashed line for less than or greater than. And it's a solid line if they're an equal to. So less than or equal to or greater than or equal to. After you have your line drawn, now you are going to test a point that is not on the line. So if you substitute that point in and your ordered pair is a solution, then you are going to shade. You are shading the half plane containing that point. And if that ordered pair you tested is not a solution, then you're shading the other half plane. So let's look at some examples. Our first one, we have y is less than x. So we need to determine what kind of line we're drawing. So here we are drawing a dashed line. So if you think of the equation y equals x, there's no y-intercept here. So our y-intercept is starting at 0. And then we have our slope. Our slope here is 1. So rise 1 to the right 1. So now we can draw our line. We are drawing a dashed line. So there's two ways you can do this. When you use your ruler, you can do it every so often to do a dash, or you can draw your line and take your eraser and then go in and make it a dash. Whichever one is easier. In my case here, I'm going to be drawing and then erasing. But if I was doing this in person, I'd be drawing it every so often to make that dash line. So now that we have our dash line, we need to figure out if we're going to shade this part of the graph, the top part, or the bottom part. So we need to pick a point that's not on the line. So let's pick right here. So that is negative 4, 0. So if we substitute that in for y is less than x, or y is 0, our x is negative 4. Now, is this a true statement or a false statement? Your inequality is supposed to be the larger number. Here, negative 4 is smaller than 4, so this is a false statement. So we are going to shade the other side where it's not. So it's helpful to have a color pencil to color this whole side in. Now we need to see which of these three, or if all three of these are solutions. So your solution is going to be in the shaded area. Since it's a dashed line, it cannot be on the line. So -3, 2. We go over -3, down 2. That is not a solution. 0, 0 is on the line, but it's a dashed line, so that's not a solution. And then over 2, up 1 is in our shaded region, so that is a solution. Let's look at the next problem. We have y is greater than x. So greater than is also a dashed line. So we have the same equation. So we're going to start at our y-intercept, which is 0. And our slope is 1. We are going to draw our line. And we are drawing a dashed line. So I'm going to use the eraser to create the dash. Now we need to figure out our shading. We can use the same point. -4, 0. So, -4, I'm sorry, use 0. 0 is greater than -4. Is that a true statement? Yes. It's a true statement. We are going to shade where that point is, the side it is on. So you want to shade this whole region with a color pencil all the way through. Now let's check some points. -3, 2 in our shaded region, so that is a solution. 0, 0 is on the line. Since it's a dashed line, it's not a solution. And 2, 1 is over here in our non-solution area. Let's look at the next one. We have y is less than or equal to x. So that is a solid line. It's an equal to. So we're going to draw our line with a solid line. So start at the y-intercept, which is 0. And our slope is 1. And it's a solid line. So it's a normal line. And we are going to shade. We can use the same points that we've been using. So -4, 0. So is 0 less than or equal to -4? No. So we're going to shade below the line. Since we are shading below the line, and it's a solid line, anything in this region and on the line is going to be a solution. So we have -3, 2. We go over -3 up 2, not a solution. 0, 0 is on the line, but it's a solid line. So that makes it a solution. And 2, 1 is in our colored in region, so that is also a solution. Let's look at the last example here. We have y is greater than or equal to x. Greater than or equal to is a solid line. We have the same equation. So our y-intercept is 0. We have a slope of 1. solid line that we're going to draw with a ruler. And then now we need to figure out our shading. Let's pick a point here. Let's just pick a different point. Let's pick 2 right here. So we have 2, -1. So we have y is greater than or equal to x. So our y is -1, our x is 2. So it's -1 greater than or equal to 2. It's not, so it's false. So we're going to shade the other side, which is above the line. So now let's look at our solutions. -3, 2. Go over -3, up 2, that is a solution in our region. 0, 0 is a solution because it's on the line and it's a solid line. 2, 1 is not a solution. Let's try the next one. We have y less than 3x minus 2. So we are going to start at -2. We have a slope of 3, so up 3 to the right 1. Now we can draw our line. We have a less than, so it's going to be a dashed line. Don't forget to make it a dash. And then we are into shades. So we're going to pick a point here. The easiest point to pick is 0, 0. That's not on the line. So make the math a little easier to figure out. So we have 0 is less than 3 times 0, 0, so -2. Is this a true statement? It is not. So we are going to shade the other side. So let's look at these points. -3, 2 is not a solution. 0, 0 is not a solution. 1, 4 is not. 2, -5 is. 0, -2 is on the line, but it's a dash, so it's not. -4, -2 is not. 2, 2 is. -2, 3 is not, and 3, 0 is. Okay, let's look at the next one. We have a y-intercept at +4. We have a slope of -2, 3. So go down 2 to the right 3. Draw your line. And determine if your line is going to be solid or dashed. Here it's just less than, so it's going to be dashed. Now our shading. Let's try the point 0, 0. So 0 is less than 4, because -3, -2/3 times 0 is 0, so it cancels out. Is this a true statement? It is a true statement, because 4 is larger than 0. So we're going to shade where that point is. Now let's try our solution points. -3, 2. That is a solution. 0, 0 is a solution. 1, 4 is not a solution. 2, negative 5 is a solution. 0, negative 2 is a solution. Negative 4, negative 2 is a solution. 2, 2 is a solution. Negative 2, 3 is a solution. And 3, 0 is a solution. Okay, let's look at the next one. Y equals negative 4. So here we have no x. It's a y equation. So that is going to be a horizontal line at the value negative 4. Think of it as a y-intercept. There's no slope, so it's just going to hit at the y-intercept. So now we need to determine if it's solid or dashed, and it is a dashed line. So created a dashed line. So if we test a point 0, 0, so just 0 is greater than negative 4. Is that true? It is true. So we're going to shade above the line. Okay, so let's test our point. Negative 3, 2 is a point. 0, 0 is a solution. 1, 4 is a solution. 2, negative 5 is not a solution. 0, negative 2 is a solution. Negative 4, negative 2 is a solution. 2, 2 is a solution. Negative 2, 3 is a solution. And 3, 0 is a solution. Okay, this next one here is not in our slope-intercept form that we can grab. So we need to rearrange it. So we have 2x plus 3y less than or equal to 6. We move our 2x over. So we have 3y less than or equal to negative 2x plus 6. Divide everything by 3. So y is less than or equal to negative 2 thirds x plus 6 divided by 3 is 2. So our y-intercept is 2. Our slope, negative 2 thirds. Go down 2 to the right 3. Draw your line. Now this is an equal to, so it's going to be a solid line. Now we need to test a point. We're going to do 0, 0. This is not on the line. It's going to be the easiest one to do. So, is 0 less than or equal to 2? That is a true statement, so we're going to shade below the line. So let's test our points. Negative 3, 2 is a solution. 0, 0 is a solution. 1, 4 is not. 2, negative 5 is. 0, negative 2 is. Negative 4, negative 2 is. 2, 2 is not. Negative 2, 3 is on the line, so it is a solution because it's a solid line. And 3, 0 is a solution because it's on the line. The next one here, let's graph it. Y-intercept's -1, slope is 3/2, so up 3, to the right 2. Draw your line. And it is an equal to, so it's a solid line. And let's test a point. Let's choose 0, 0, since it's not on it. So 0 is greater than or equal to -1. That is a true statement, so we're going to shade where 0, 0 is. Now let's test our points. -3, 2 is a solution. 0, 0 is a solution. 1, 4 is a solution. 2, -5 is not a solution. 0, -2 is not a solution. -4, -2 is a solution. 2, 2 is on the line and it's a solid, so it's a solution. -2, 3 is a solution, and 3, 0 is not a solution. The last problem we're going to look at is an x equals equation. So if x equals a number, that's going to be a vertical line at that number. So -2, where x is -2 is right here, and it's going to be this vertical line going straight up and down. Now we need to determine if it's solid or dashed. Is an equal to, so it's a solid line. Now we need to do a test point. Let's try 0, 0. Substitute 0 in. 0 is greater than or equal to -2. That is a true statement, so we're going to shade where 0, 0 is. Now let's try our test points. -3, 2 is not a solution. 0, 0 is. 1, 4 is. 2, -5 is. 0, -2 is. -4, -2 is not. 2, 2 is. -2, 3 is on the line and it's an equal to, so it is. And 3, 0 is a solution. So that is your lesson on graphing inequalities. Please reach out if you have any questions.